So I'm going to talk about avocado crop load management with manual fruit thinning, and so that is a bit about the irregular bearing as well. I think I'd better add from the start just to avoid confusion. In our situation, we're looking at the avocado crop load as there being, sometimes there's too much and we're trying to knock that down a bit. And so Harley's sort of going the other way around. There's not enough and you try and lift it up. So there's definitely two different approaches. We're not doubling up or, wasting anyone's time. Just want to get that out there right from the get-go. So for what I'm going to be talking about is about sustainable Hass avocado yield. So this is regardless of whether the yield is going up or down or being different from year to year. It does do that, but at the same time, no one actually knows what the sort of correct amount is for an avocado tree, just per tree or per leaf area, per inflorescence. No one really knows. Something that is cited very often is 32.5 tonnes per hectare, calculated by Wolstenholme, or Nigel Wolstenholme, in 1987, that's right. And that was quite a theoretical calculation done by, I think he did a calorie bomb combustion of an avocado and an apple, and he did oranges as well. And then he calculated how many kilojoules there were per tonne for avocado, for apple, and then assumed, okay, 100 tonnes per hectare for an apple is pretty good. So then if you divide the 100 tonnes apple divided by the energy of the avocado, then that gives you this 32.5 tonnes per hectare, allegedly consistent. Definitely people have achieved more than this. Here the odd 40 tonne every now and then, but consistent, who knows? And also his estimate is based off highly productive apple orchards where the canopy is manipulated to death. So ultimately it's not entirely based on anything. It's a great target though, but it's not a real answer to knowing what the avocado crop load really is. And then also that is complicated even further by inconsistent bearing habits, irregular, the alternate bearing. They just seem to do what the hell they want, to be honest. So what we did, this is with Horde Innovation funding, we embarked on some research to determine a value for sustainable yield of the Hass avocado. And I'd specify Hass avocado because it would be totally different for lamb Hass or shepherds or reeds or anything else. So at this stage, we've got almost 3 years of data. So we started in 2020, and we have 2 complete harvests at this stage. So the way we did this is, so you can think, we're trying to get a sustainable value and have that tied to like a quantifiable number. And so you can do that by the surface area of the tree or the height of the tree or the canopy volume of the tree, and they all change over time. So the thing we ended up settling on was fixing it to inflorescences. So we would thin inflorescences to different numbers of fruit after flowering. And then that way, the number of inflorescences will change as the tree goes bigger, of course, but we are targeting each inflorescence the exact same way every year. So that's trying to be sort of a consistent way every year. So 3 treatments and the control, and that's applied to 20 trees. So each treatment, there's 5 of them. So the treatments themselves, so for treatment 1, every single inflorescence, we thinned it to 1 fruit post-bloom. That's assuming that inflorescence had fruit. If it didn't have fruit on it, well, it doesn't matter. For treatment 2, all inflorescences are thinned to 2 fruit post-bloom. And so there's a caveat on that, because sometimes, in fact most of the time, most of the inflorescences didn't have more than 2 fruit. And so not much thinning was done on those trees, and that's important to remember for later on. And treatment 3, the same deal, but 3. And once again, that was the issue of actually finding the inflorescences that had more than 3 fruit kept on them. So when we applied them, the treatments that were applied when the fruits were about 10 millimetres in size. So we're trying to do it at a point when it's after sort of well enough after flowering that we know that the fruits are actually going to think about hanging on. There is a number out there in the research that I think it's below 6 millimetres, that fruit below that size, you can't guarantee that they're actually fertilised and are going to go the whole way through. Now, I just need to mention with this picture, I didn't realise it was a competition to see who had the oldest worker with them, but he's not 94, but Al Jacobs here, he's 75 and he's up a ladder, so that's pretty good. He was an absolute machine and he helped with a lot of the thinning and flower counting and things like that. Okay, so over the trials we've measured many, many things: tree size, fruit number, we counted every fruit on every tree, fruit size over time, many mineral sampling times, total yield done via the harvest, and the inflorescence number. And so one of the most important factors though is the outright yield. So I will show some of that. So in this graph, so the left and right, these are showing a yield, but they're showing a yield as based on the average fruit count instead of actual weight. The only reason that's done is because we have the first harvest in blue and then the second in there. There's no third harvest yet, so this is based off the last count we did, which was this month. It was on the 19th, so it's quite recent. You can expect that to go down a little, but from historically we find that after you've had that summer drop, you don't lose many more fruit. So as these numbers stand, we can expect this to be representative of what the harvest is going to be when we finally get to it in December or January. So what we have here, so in our first year, getting wobbly there. The treatment 1, so that's 1 fruit per inflorescence, 2, 3, and the control. So the first year we applied it, there isn't not much of a difference between all the treatments. And we attribute that to being that we've applied the treatment, the tree is starting to, it's responding to the treatment. So no major changes there. The second year was a bit different. So in our treatment 1, this is where we have removed the most fruit. And in this case, the responding yield wasn't that different. Now you compare it to these other ones, the 2 and the 3, where we didn't remove anywhere near as much fruit as we wanted. Now they've had much larger decreases in their yield because the way we're thinking about this is that in this first year, because we didn't remove enough, they're effectively stealing resources from the next year, and the response is that there is a lower year. The same applies to the control. Note that the error bars are very large, so it's not that different. Now, when we get to the third year, this is a bit more exciting. I think this is matching what everyone has probably got in their orchards, where they've got just tons of fruit hanging off the trees. So in our treatment 1, we've removed the most fruit, and as a result, we have had a massive increase in the amount of fruit on the tree. However, when you compare it to these other treatments, where we have either hardly removed any fruit or not removed any at all, it pales in significance. And in fact, the NS means non-significant, so there's no differences between these 3 years. Whereas over here, the significant differences between those 3, significant differences, significant differences. So that's quite positive for us, and the way we take it is that treatment 1, we're thinning to 1 inflorescence per tree, and what we are able to do with that is produce a more consistent yield. Now, it's important to address this. We're getting these humongous yields here. So what's that going to do to the cumulative yield? It may be that, sure, we're getting a more consistent yield here, but whoop-de-doo, if you can get just so much in these years where the trees go gangbusters, if you end up with more in the end, it might not matter. As it is, with the cumulative fruit count, no differences between any of the treatments. So they're all producing the same amount of fruit. It's just that some of them are being more consistent than others. Okay, so I'll show you the genuine weights. And I've also included an estimated weight for 2023. It's only estimated because I've basically gone, there's that many fruit, I'm going to guess the fruit will be 300 grams when we harvest them, and then that's the weight it's going to be, with 300 grams being the weight we've had roughly the weight we've had in the last 2 years. Actually slightly lower. So that's our treatment 1. The cumulative is 64, so it's an average of about 20 tonnes per year. As before, these aren't very different. But in here we've got these ridiculously high ones. And as I said earlier, that is presumed because not enough was removed from these, or none was removed at all. And so they starved themselves for this year. And then because there wasn't much this year, they've built up too much. And now they're responding with this ridiculous amount of fruit. And so as you can see, 30 tonnes is totally achievable, but it isn't a consistent trend. Okay, this is an important one to look at as well. So we counted every inflorescence on each tree, and we've done that 3 times now. No, 2 times, sorry. We don't actually find any relationship between the inflorescence number and the amount of fruit that gets set on the tree. This is once again our charming R squared, and it's written in a different notation, but that just means there's lots of zeros in front, so it's very zero. You can have this absurd amount of inflorescences, so that normally an inflorescence has about 100 flowers on it, so that would be 350,000 flowers, and yet it did, I don't know, that's probably 13 or something, whereas in this sort of central part, about 2,000 or 200,000 flowers, and they're able to do 400 fruit per tree. Yeah, we're not finding anything to do with the actual number of inflorescences here. We've also looked at the canopy volume. All the lines are very close. The standard errors are all overlapping. There's not much difference going on here. Over time, we're finding that at least our treatment 1, which is in blue for some reason, they might be gradually getting away and getting bigger as they're ending up with extra resources. So we're knocking off excess fruit, and the tree's going, well, what do I do with this? I'm going to put it into the leaves, potentially. That remains to be seen going forward if that trend continues. Okay, so we're getting near to the end. So we've done thinning of inflorescences and so in what we've done, thinning it to 1 fruit per inflorescence has produced the most consistent crops over the I guess 2.5 years we've been doing. Consistent 20-ish tonne per hectare crop. The other treatments where hardly any fruit were removed and the control where none were removed, they all have the same cumulative yield, but the distribution of that yield over time is more variable. So going forward, we want to do 1 more harvest and possibly do 1 more manual thinning and a tree count to follow up. So we can follow up what's going to happen with next year. There's much speculation about what next year's crop is going to be like, whether it's going to be another big one or not a big one. So that's what we have to look forward to. Now, obviously there's an issue with manual thinning. No one's going to do that. I don't like doing it, and I actually do it. It's not viable commercially, so we're looking into it's a review into the mechanical and chemical options instead. So in apples, there's like 1 million different chemical options for removing excess fruit and flowers. Not all of them will work because there are products that work on apples which then don't work on citrus or olives, for example, which are, they're all quite different taxonomically to the avocado. And the challenge is finding things that have a conserved action over many different varieties of plants. So we're looking into that. Also the mechanical thinning as well, because that seems to be the popular thing at the moment. Most of the research is going into that now with regards to thinning, then into the chemical options. Okay, and so that's all for that. Thank you very much for listening. I think the key take-home point of that is that we've thinned to 1 fruit per inflorescence, and in doing that have removed a reasonable amount of material from the tree, fruit that is, and by doing that we have, I believe, been able to create a more consistent yield on Hass avocado trees as compared to our control. And in doing that we haven't actually harmed the cumulative yield, even though we've lost those massive years that you seem to get every now and then. Thank you again.
The thinning of 1 fruit per inflorescence, do you think with mechanical pruning, I doubt that you'd be able to achieve that level of accuracy, so do you think it matters whether it's off the same panicle or not?
Well, to be honest, I don't discount the mechanical thinning, but the mechanical thinning requires a very flat canopy to work on, so which, you know, no one's going to want to do that, because avocados are just a lumpy canopy. They're not like apples, they can't be pruned to a 2D situation. Other things we've looked at and looked into, so we've started by trying to quantify it to the inflorescence number. There will be better things, such as leaf area, which can be measured on mobile platforms. Dario talked earlier about the orchard cartographer, the Green Atlas platform. That can measure leaf area, and that would be a better thing to quantify the amount of fruit you want to remove to. Because, yeah, doing it to the inflorescence, it's very hard. And with a mechanical system, no, it'd be... Unless you had a really good way of getting that orchard into a sort of a consistent way where a mechanical thing can go in and out into it, yeah, you might be dreaming. Yes.
Declan, one product that we use as apple growers is a product called Culmite, which is a desiccant, and we can get away with that because we have a protracted flowering period in the apple industry. With regards to avocados, do we get that protraction in terms of pollination? Like, you know, we may have fruit that's 10 centimetres, 6 centimetres, some flowering. Because if that's occurring, then potentially we could burn off the very, very late flowers without harming the crop.
Yes, or even the very, very early ones, or well, that could be dangerous, to be honest. The late one would be a better one to target. There are differences in the fruit size. We don't have it as extreme as they do in Queensland. I know they can have fruit like this big, and then they have one's golf ball, and it's all from the same like flowering season. But we do get that difference, the protracted sort of setting, I would say we do.